Yeah. Like for 6:30. Which one do you need?
I heard that mountains instability.
Okay, have your attention, we'll get started. I'm Professor Tripoli, and today I'm together with Zoe here. We're filling in for Michael, Professor Morgan, who's busy with another matter. And so today I thought I'd cover a couple things that I thought were interesting in the past week. And one of them is the floods that occurred in Italy. Some devastating, I should say catastrophic floods occurred beginning Sunday and then Monday last week, Sunday the 4th and Monday the 5th. This is a picture. I'll just show you some of this article here. It's in Italian, so I can't read it, but you can make out some of it. The 178 millimeters of rain in an hour in this location here, 377 millimeters in 3 hours, 740 millimeters in 12 hours. That's what 740 millimeters is, about 15 inches, I think. 6 inches maybe. But these are very large amounts. And this is kind of the distribution of it. This is in the Liguria region of Italy. Right here is Genoa. This region up here is the Piemonte region, kind of a region of the Alps. And Milan is up between Genoa and the Piemonte region. Lake Como is up in here. And so you can see the very, very high precipitation amounts, over 500 millimeters in the whiter areas over here. And these are very devastating because in Italy it's a very mountainous region, particularly in the north. And when these kind of rains fall, and they typically fall on the slopes of the mountains, it produces these torrential flooding rains coming down the hillsides that cause a lot of problems. I haven't been able to read into this to see how many people actually died, and quite often no one dies in these things. And the reason for that is because they've become very good at forecasting these events through the use of mesoscale models. And in doing so, people just get out of the way. That's what it happens. These are some of the amounts occurring over a period of time, beginning on the 4th and going into, excuse me,
Yeah, it's mostly on the 4th GMT. It starts at 0Z on.
mostly on the 4th, yeah, that's right. And then a little bit into the next day.
Yeah, a little bit.
Yeah. There's some more pictures of the floods. Torrential. And probably these older houses that are here, they've seen this before. They just rebuilt. So the reason this is of some interest is because I think there's evidence, and I haven't proven this by any means, but I think there's evidence this is a consequence of Hurricane Sam in the Pacific, in the Atlantic, that we've had the last several days. Before this. Remember, during last weather watch, Hurricane Sam was kind of roaring to the north, moving into the extratropics, and it was producing a jet stream. And let me show you this now. This here is an animation of all the jets around the world. And I'll just describe this because it's a nice long animation. It's about a week or two long. I guess it begins at the beginning of this. The beginning of this is the 20th of September, and the end of it is still in the future from now. So this is a few weeks of animation. And these are the jet streams around the world, and these jet streams are colored by the potential vorticity, where the hot colors, the reddish colors, are very low potential vorticity as you approach zero. Now, the potential vorticity, I'm just doing the magnitude of the potential vorticity here to show you how low the magnitude is. As it approaches zero, it doesn't make a lot of difference whether it's positive or negative at that point. But it matters how close it gets to zero. And you can see that these jet streams, many of the ones going from east to west in the northern hemisphere, have this colorful belly to them to the south, and that represents regions where tropical air is pushing up against the jet from the south and streaming in, forming the southern part of the jet. So essentially, any of these jets that are colorful are classic subtropical jets because they're receiving flow from the tropics on their equatorward side. You can see the same number of jets in the southern hemisphere as the northern hemisphere. The height of these jets tends to be around 12 kilometers, 12 and a half kilometers. And at this point, on the 20th, we have a little, something going on here in the Atlantic, but not a lot. A little ridge here. These are all fairly weak jets. John talks a lot about polar jets, and we have this argument that I claim there's no such thing as a polar jet. There's really only old subtropical jets that look like polar jets, the way we define polar jets. And it's my view that subtropical jets move into the extratropics and they age and eventually become like polar jets. And I think that's what this is, and this, you can see it's still got a little color left on its belly, but eventually that color fades. Look at these jets in the southern hemisphere. You got 1, 2, 3, 4, 5, 6 jetlets. And what you can see happening is they're entering the polar night jet. Now this jet down here, this big massive jet to the south, is what we call a polar night jet. Okay, a polar night jet occurs in the winter hemisphere, and it occurs because of a contrast between regions that have ozone and regions that don't. And ozone regions are receiving sunlight and heating, so you got this heating contrast. This occurs way up in the stratosphere. So if I tilt this up and look at it, you see this polar night jet goes right out of the top of this picture, right? And the top of this picture, if I put a probe in here, put this probe up here, this is at 25 kilometers. So at 25 kilometers, this jet is going right out the top, right? And so it's a very high jet, but down inside of it, you can see these subtropical jets actually coming in. So if I look over here, I see a subtropical jet entering there, one entering here. So when I animate through this, interestingly, you can see these subtropical jets interacting with the polar night jet. Subtropical jet's about centered at around 12 kilometers. The polar night jet is centered up there at 25 to 30 kilometers. And so, you know, and so it's much, much higher. But the subtropical jets, you can see them inside the polar jet. This surface here is a surface of 40 meters per second, which is about 80 knots. So inside that surface, everywhere, it's at least 80 knots from the west. And what you can see are these subtropical jets that are at least 80 knots from the west getting inside of the polar night jet. And how can that happen when they're at such different elevations? The reason is because the thermal wind associated with the subtropical jet through a deep layer above the jet changes the thermal wind effect that's dissipating the polar night jet downward. So it allows the polar night jet to bridge downward, extend, to grow downward, and the subtropical jet to grow upward till they meet each other. So when I look at this from the side, you can see that it just extends downward in regions where the subtropical jet is interacting with it. And I think this is a very poorly understood, neglected phenomenon. I think this interaction is absolutely essential to the heat transport in the atmosphere and the way polar outbreaks occur. And I'll get into that at another time. However, right now we have a very strong polar night jet. If I look at the ozone, I wanted to show a picture of that. Here's the ozone. The bright colors are where the ozone is strong. The blue colors are where it's weak. You see there's less ozone in the northern hemisphere toward the poles, but not totally gone. In the southern hemisphere, the ozone is almost zero around the south pole. Very sharp gradient, and it's this sharp gradient of ozone. I'll turn it off and on. See, that's right where the jet is. So the jet bridges that on-off thing with the ozone. There are articles out there that the ozone hole this year, which is starting to make itself known right now as the sun tries to rise, or does rise on the southern hemisphere poles. The ozone hole is one of the strongest or least ozone in a long time, for whatever reason.
We get Professor Hitchman in here one of these weeks to talk about this year's ozone hole.
Yeah, Professor Hitchman would be the one to talk about that. But this is a very strong polar night jet. We expect that if we were to look at this same plot about a month from now, the polar night jet might be almost entirely gone in the southern hemisphere. And instead, we'll start building the same sort of jet at high stratospheric levels up here where the ozone is just now weakening and the cooling is commencing. However, what we really want to look at here is what's going on prior to the floods. Now, up in here is where the floods are. And if we go back to the beginning here and step forward in time. Oh, I also want to turn on surface pressure.
Is it possible to zoom in on like the North Atlantic at all?
You can see it.
Well, I'm just saying if you can use the middle mouse button to zoom in.
Oh, zoom in on North
Yeah,
Atlantic.
make it a little bit easier to see what you're pointing out.
Okay, this is surface pressure. I'm just plotting it over the top of this. And what we're going to look for here is where Sam, the tropical cyclone, is and how it relates to this jet stream. So you see this kind of a weak jet stream, an old subtropical jet, if you will. And here's Sam, way down south in the just off of the Leeward Islands. And this is on September 25th. And so if I move forward in time, see the tropical cyclone is so small that it hardly can hardly show up on this big of a plot. But here goes. So this is about October 2nd. Was October 2nd the last weather watch?
It would have been Saturday, I think.
That would be Saturday, so this is the day after the last weather watch.
That would have been Friday night, 0 Z on the second week Friday night.
Okay. So at this point, where the where Sam is near Bermuda, you see its outflow coming up here. This is lighting up this subtropical jet. In fact, it's creating this subtropical jet. So this outflow is mass that was inside of Sam. It's now moved forward and streaming in this way, and it's combining with mass coming from the north to create this subtropical jet. The mass that's exhausted from the tropical cyclone is very high mass at very warm potential temperatures, which means that the geopotential or potential energy at the outflow levels, which run about 360 to 380 K, those outflow levels are filled with extra mass. The isentropic layers are bulging with mass and high potential energy, and that's filling into this. Now the floods that occurred over here in Liguria are 2 days off from this, and that's all. But look at this. You see this come down here. Now what's happening with this jet is creating a subsidence region to its north. And that subsidence region is pushing down stratospheric air to create a big potential vorticity anomaly. So at this point, a potential vorticity anomaly is actually over Spain or in Portugal, right in here, and I can look at the three-dimensional surface of potential vorticity answer somewhere. Right here. Now the bright colors in potential vorticity, let me take off the jet for a minute. The bright colors in potential vorticity are I'm shading the potential vorticity surface by height above sea level. So the bright colors are high elevated potential vorticity surface, and the low ones are potential vorticity surface that's sunk down. So what I have is this shelf that's developed in the outflow layer, where the tropopause is basically folded over and moved down to very low levels over Portugal and Spain. So the tropopause down there is, I think I've done some cross sections through there, it's around 500 to 700 millibars, very, very low, very, very high potential vorticity on the 700 millibar or 500 millibar surface right across this. And if I step, well, I can also look at, let me go back up here, look at just the vorticity itself. And you see the vorticity itself is a very high value of vorticity over here. This is at about 500 millibars. Okay, so, get back down to this one. With the potential vorticity, I'm going to put the height and speed back on. So here's this jet, and this very low potential vorticity anomaly that's formed in here, that's driven by the circulation around that jet in the exit region, which is forcing air down on the northerly flow side of this jet stream. Here's a southerly flow coming out the other side. So then if I step through to the fourth, here's the fourth at 6 a.m. and then later on, right about this time in here, we get this very low potential vorticity anomaly moving right into the Liguria region over here. And it's the vorticity advection that's going to enhance this flow. Now, where's my, I don't know if I have enough contouring interval to see this low pressure. I'm back up to the fifth over here. Well, if you look hard, and it's hard to see here, there's actually low pressure that develops at the surface as a result of this effect. So this is where it's actually happening. So it's my contention that, as we've seen in a number of cases I've studied in much more detail, the potential energy placed in the upper level flow by the tropical cyclone can create a kind of a cyclogenesis in the Mediterranean. I've studied a number of these storms, probably 5 or 6 of them that I've done in a lot more detail. And in each case, you can see some of the same sort of effects. We actually did a study of about 20 or 30 Mediterranean floods that I was involved with, but I didn't do myself. And they found that of 20 or 30 floods, there was on the order of 75 or 80% of them occurred just after a tropical cyclone in the Atlantic. And we all know that the Mediterranean floods occur primarily during the fall season, September, October, and somewhat into November. Those are the season for Mediterranean floods. And we struggled for a long time trying to understand what was so special about that season. It was a warm Mediterranean versus the cooler air moving in from the north, the airclinicity there. That's possibly part of it. But in the end, I think we realized that this is coincident with the tropical cyclone season of the Atlantic. And that seems to be one of the major effects. And I think this particular flood this week was an example of it.
Is that like a forecasting tip over there, where when they see a strong cyclone in the Atlantic, tropical cyclone, that they put
Yes.
up their red flags and look out for
Well,
flooding? a couple
not
days later?
everybody, but the guy named Penis Alpert, who's a meteorologist from Israel, Tel Aviv, he has told me after we were telling these things, he said, well, it's a general rule with all forecasters here in Israel that when you see a tropical cyclone in the Atlantic, you count 10 days and then watch out for something happening in Israel.
Hmm.
So, I think in some circles, that's true. Other circles, like the people in Catalonia and Italy, I don't think they ever thought of that. So it just depends on where you are.
Hmm.
Okay. Now, in terms of past week's weather, I think I'm just gonna go with this plot. Oh, it's interesting here. I wanted to show this one thing. I think it's if you look at this relationship of the tropical cyclone and the jet, here's the tropical cyclone approaching the jet stream, which is from its outflow. But then, toward the end of its life cycle, it crosses the jet stream and ends up on the other side and becomes much stronger. We often interpret this as extratropical transition. I suspect that the tropical cyclone may be feeding energy off the energy it exhausted. Once it crossed the jet, I think it gets on the other side of the baroclinic circulation and helps drive the cold air underneath and down and over the top, and I think it enhances the tropical cyclone circulation overall. And that's this extratropical transition creates an effective bomb. This is kind of a bomb cyclone in the Atlantic, forming out of the circulation of sand. But it's a different circulation. Once it crosses the baroclinic zone, now you have cold air on one side, and cold air becomes the dominant mechanism. Cold air sliding under warm air becomes a dominant mechanism of releasing energy in the storm. And I think it gets another boost. It also gets a boost by the low inertial stability that comes in aloft that allows divergence at the upper levels to be much stronger without resistance from inertial effects. So, in a general sense, here's our jet stream pattern going into the future and what we've had in the past week as we go around this loop. You can see that the northern hemisphere wave train up here is becoming increasingly intense. And if you look at where these jet streams are coming from, they are mainly coming from tropical pushes, tropical plumes on the underside is what's driving these northern hemisphere jets to intensify, as opposed to cold air surges from the north. There's not much cold air at the poles yet. And I don't think we'll see surges of cold air at the poles until we establish a polar night jet. And there's not much evidence that there's any kind of a polar night jet in progress right now. You may see a little bit here and there, but by this time, in the beginning of November, let's say by the first or second week of November, I think the polar night jet will have established itself in the northern hemisphere, and I'm guessing it will. And the one in the southern hemisphere will be almost completely disappeared. We'll see. And maybe this year's a little strange because of the ozone hole down here. When you have an ozone hole down there, I don't know what the implications are thought to be, but one thing I could reason out logically is that if there's an ozone hole, so you don't have any rudimentary ozone, or at least not very much ozone, appearing in the southern hemisphere, then even if the sun comes up, it's hard for it to heat that air at the South Pole, right? Because it needs the ozone to absorb the UV radiation. So I wonder, and I don't know, but I wonder if at the South Pole we'll have a hard time getting rid of the polar night jet in the southern hemisphere. If we keep that ozone hole, they might be mutually reinforcing each other. Okay? I think that's all I have, except for the current weather, and I'm gonna let Zoe do that. So, you wanna take over?
Oh yeah, quick question, before we get off. Actually, I was interested in, like, you said there's a relationship between the tropical cyclones in the Atlantic and flooding events in the Mediterranean and, like, Israel.
Yeah.
Does it matter, like, the path of the cyclones in the Atlantic, or just, there needs to be one in the Atlantic?
Well, it's not the actual cyclone that's hitting them. So the cyclone doesn't have to have a trajectory into the Mediterranean. This one did, right? This one went up into the Arctic Circle. But what the cyclone does is it creates a subtropical jet stream. And a subtropical jet stream contains a lot of energy. And I'm not talking about the kinetic energy of the jet. That's insignificant. The kinetic energy of the jet is a symptom, but it's not the cause. The reason why those subtropical jets exist is because of the huge amount of potential energy that's thrown up there by the convection in layers. We can think of convection as being an overturning circulation, but that's just a way we think about it. The actual overturning doesn't finish until the air comes back down somewhere. Basically, the convective disturbances put it up, like tropical cyclones, but they don't bring it down. In fact, it's probably going to go down somewhere in the northern hemisphere in the middle of the baroclinic system, not even in the tropics. So what we're doing is we're putting all this stuff up there and suspending it, and then it goes into the extratropics where it raises hell.
Gotcha. Thank you.
Okay?
Thank you, Professor Tripoli.
So I'll talk about current conditions and then look at least at a bit of a short-term forecast. This is the week-long infrared view, just to get a sense of what's happened since the last weather watch. You can see Sam, which Professor Tripoli is talking about, developing and moving its way out of the view farther northeast. You can see the system that started to impact us yesterday. This is now on the 7th, mid-latitude cyclone with subtropical origins developing and interacting and giving us some rain that we saw yesterday. Also associated with it, which I'm not going to go into, but if anyone wants to talk about the severe weather that happened in Alabama, Mississippi, and now there's some strong thunderstorms on coastal Georgia that also is associated with these mid-latitude cyclones going through. As we've kind of talked about the last weekish, the tropics are not nearly as active. There's the Saharan dust layer that's suppressing some of the convection. At the end of this loop, there's a small invest area of a potential tropical system off the coast of Carolinas, but it doesn't look like it's going to develop into much. Again, exit out of this. So this is just more the short-term view, what we were seeing at the end of that loop. We'll go over to the west coast and see what's happening over there. California is getting some much needed rain right now. We'll see there's a relatively strong MCS associated with the storm south of Georgia. And then, as we've noted here, pretty cloudy, and we had dense fog this morning. That's letting up somewhat. We'll also, I wasn't able to get a good view of it, but you can see some, if you actually zoom back in, you can see some valley fog starting to form up in the northeast, as you see the clouds dissipating, which is actually fog, but I looked at the northeast view, and it's still pretty fuzzy.
Oh,
But
okay.
I might have not been looking at the correct link, but we'll start seeing some fun fog as we get further into the fall season. Yeah, click out of this.
Oh, can
Yeah.
I wanted to point out, are you gonna go to the western
Yeah,
side? Okay, I'll
that's
look at
next.
that.
So, also in the west is now infrared view. We don't have any daytime hours here yet. Two notable features. One, we're getting a plume of tropical air making landfall on California, and we'll see in the surface maps, radar, there's actually some precipitation associated with that. Is that what you're going to talk about?
Yeah.
Do you have
Well, I
any?
wanted to point out that with these subtropical jets, it's not just tropical cyclone. Subtropical cyclones make fairly strong subtropical jets, but all tropical convection can contribute to a subtropical jet along the ITCZ. But in this case, we have a cluster of clouds. You can see them in the sort of the middle right of the picture there. Those cluster of clouds around the ITCZ, not that, but down on the ITCZ. Yeah, those things are sending out outflow that's creating a pretty enhanced subtropical jet there. And I think that is because, in looking at this, there's a Walker circulation where the air is rising in the maritime continent, and there's an MJO that's moving across the maritime continent or moving from India toward the maritime continent and into the Pacific. But out ahead of it, there's some mixed upward motion. It appears to be Kelvin wave type activity that's moving from the west to the east, that's enhancing these convective cells here as it moves through. That's what I'm guessing is happening. But something has to give these convective entities a reason to flare up right where they are. And it seems to have something to do with that.
Yeah. So IPCZ, intertropical convergence zone, is still pretty active in the northern hemisphere. See that shift in the southern hemisphere eventually. Yeah, associated with this tropical plume of air coming up to California. We're also seeing a mid-latitude cyclone making landfall in Aleutian Islands, Gulf of Alaska, bringing it some rain and snow as well. So it's pretty active weather systems across the U.S. right now. Yeah.
So that band of clouds and precipitation going to California, that would be considered like an atmospheric river, right? Would you define that
I don't-
as?
No.
It could be if you had the right threshold, but atmospheric rivers have specific moisture and like water transport thresholds, so that I don't think this is reached.
Pete, can you bring up the precipitable water? Do you have that? Is that only, it's probably not part of the satellite. I have it in
You want it
mind.
on your J page?
Yeah, you get it off of there.
Yeah, atmospheric rivers have a very specific definition that, yeah, I don't actually know what it is, but it doesn't look intense enough based on both the satellite and having looked at some of the precipitation.
Let me just try that. The 6E1?
Yeah, we've been having.
The
some
6E1
issues
was complete, yeah.
with it. We've been having some issues with data not coming in from NCEP, so there's some gaps in data.
Yeah, there's no big, real plume of moisture with that right now. Well, look in the beginning, stop at frame 1. Yeah, there is a plume of moisture at that point. That's deep precipitable water. That's the integrated moisture in the column. And so there is a maximum in that location at this initial time. So, yeah, it's an atmospheric river for a moment anyway. Yeah.
Maybe not quite.
It may not be by the
landfall.
definition of an atmospheric river, but it's definitely
It
transporting.
may not be long enough or last enough for it to be a river, but that's usually what they are. The atmospheric rivers connect into the subtropical jets.
So yeah, next thing, looking
What were we
in
doing
now
with
at,
the Pacific?
yeah, I think that was about all I wanted to mention. Looking at the radar, you can see, we can see that there's a cyclonic circulation just passing Wisconsin. It's relatively weak, as we'll see in the maps, but there's some precipitation that might hit us, but probably won't today. A trailing cold front is possibly associated with that, bringing some convection over coastal Georgia, as we noted from the satellite images lately. And then again, precipitation in California that's now moved a bit farther east, but there's some moderate rain there earlier today, which is much needed in all of the West in general, as we've seen drought conditions have lasted for a long time.
This is something you might expect to happen during El Nino
Is it?
in the south, but supposedly it's like La Nina conditions right now, and this is happening. So that's a little odd. But
Maybe a little early, wouldn't that be more like over the winter?
during El Nino, but
Yeah.
if it's La Nina, then California stays dry during the winter. You're getting a little something, it's not a
Yeah.
lot. And it's not, I don't think this is a southwest monsoon anymore, lasting into October.
Yeah.
And that usually comes up Gulf of California, not right off the Pacific
Right.
line. So, yeah.
If we look at some of the surface maps next, we can see the latest surface map. In the Midwest, we still have somewhat reduced visibility of 7 miles.
Sorry about that.
No worries. But it's improved, pretty muggy outside, as you've likely experienced, high dew points, especially for this time of the year. We see that there's haze still to most of our north and west also. Some moderate, heavy moderate rain to our east, also associated with the system. That's pretty weakly structured. Again, there's some moderate rain and thunderstorms associated with the system that we saw moving off to.
Zoe, with regard to our fog, you were mentioning about the fog, and I was hypothesizing this might have to do with drier air moving above us. Because yesterday afternoon, we broke out into fog before the sun even set.
Yeah.
And I was thinking that maybe that was because when I looked what happened is it cleared out over us. The clouds went away and it cleared out, but it was still humid at the ground. So is there any way, can we look at the 850 millibars and see if 850 millibars is dried out a lot from the surface above us? It looks still humid.
Yeah, the
Yeah.
depressions are very low, 0 at Minneapolis,
Huh,
about a little higher.
try a little higher. There must be a dry layer somewhere.
It's moist up there too.
We get a little bit of sound.
Unless it was a temporary moist layer just yesterday afternoon.
Real dry all the way till you get up above 650 or so. Even there,
Yeah.
it's pretty moist stuff. It's like Davenport. Minneapolis is saturated almost all the way up.
Well, then I think it's puzzling why the fog happened so abruptly.
This is
yesterday
12Z
afternoon.
though too, I mean, it may have been different at 0Z last night.
Yeah.
I haven't noticed it.
Yeah, I mean, fall is a relatively common time to see fog in this area, but based on the current conditions, the timing of the fog, because it's set in before nightfall when you're getting the radiational cooling, it's a little less likely, but we do have really moist air here, so.
It was weird, I was driving home last night and like I had my windows open and my windshield would fog up on the inside. So I turn on the defroster, which kind of turns on the air conditioning. And then it would start condensing on the outside of the windows. I have to run my windshield wipers. So I went that way, but it was really bizarre. I was driving down Broadway and like the inside of my windshield, it would condense and then go away, kind of like a flame kind of. It looked real weird. It was almost like I was driving through a cloud, but it was just like the fog would appear and disappear mystically or whatever. It was weird. Anyways.
Good time to spot. If we go to the west, just get a glimpse of some of the precipitation. We see again haze. I was looking earlier. There's actually a drifting smoke signal. I think at one of these locations to the east of LA. I tried to look at the weather map that Maggie pointed out last week, or the fire map last week, and I'm not quite sure how to navigate that space, and I couldn't quite see any distinct smoke on the satellite images, but still some wildfires going on there. No rain anymore. That's now moved further east in Nevada, Utah, but there was precipitation, and I guess there is still at one station. I really don't know geography in California well, but at that station there's some light rain. And then if we go north to Alaska, we'll see where we saw that Lone Lake and landfall, and we're getting some snow, so that's exciting to see some snow in the forecast, and then precipitation, rain, also associated more broadly, but a little bit of snow still in Alaska. We can jump to some of the.
Is that unusual for them to get rain in the middle of October in Alaska?
I don't know.
I mean, it looks like
I'm not
Fairbanks over there. It's getting rain.
Yeah,
Huh.
looks like most of it is rain. There's just that weather station right now that has snow associated with it. There was a few more snow a couple hours ago, but yeah, I guess it does seem late in the year. We can look at 850 millibars. And look at some of the temperatures below. But yeah. That's the storm we're seeing associated with the precipitation. Still seeing relatively warm, only -2 temperatures Celsius, associated without the cold and trailing warm front. Yeah, so it's still relatively warm up there. Nothing, even though we're getting some precipitation across the continental U.S., there's no truly strong surface level systems. The low associated with the precipitation we're getting here, or getting in the Midwest, isn't too well defined. So it doesn't look like it's surface driven precipitation. If we go up to 500 millibars, you can see a little bit more pattern. See relatively wavy mid-latitudes. This trough over at Midwest is likely causing shortwave trough causing some precipitation through divergence aloft, causing the system to precipitate. We also see this broad trough that will propagate through east with time and will lead to some severe weather potentially in the upcoming weekend. We'll see a nice cutoff low associated with the Alaska storm. Not much for bear clinic zones, also associated with this trough, and it's better at 850 to see that, but there's not really much temperature gradient across most of the west eastern US, which I think is a little atypical for this time of year. Assume that we normally start to see a little bit more.
I think it's warmer than usual. That's what it seems like to me, less baroclinicity.
Yeah. Madison itself has been, I think, it's 10 to 15 degrees warmer than average for the last few days.
What's the ice pack like? Is the Northwest Passage open now? And
I don't even have a good resource to look at that, I don't know.
I don't know.
We can look at the Madison Climate Summary, which had dutifully updates every week for us. Let's see if that is this one. You can see we just had a lot of above normal.
Yeah, our low temperatures are only at the
Marginally below the average high.
which is pretty obviously atypical, and you can feel it's staying warmer later in the season.
at the same time, the Antarctic is experiencing one of the coldest winters on record.
Yeah, the South Pole's been really cold.
And interestingly enough, when I was looking at the Walker circulation, there seems to be a north-south circulation on top of it, where it's kind of rising in the northern hemisphere and sinking in the southern hemisphere. And I wonder if there's some kind of an overturning global process that's responding to the dipole between what the North Pole is doing and the South Pole. I don't know. I'm just making this stuff up, but I don't know. I just wonder. It looked a little odd to me what it was doing, but
Yeah, that doesn't quite seem, I'm not sure about that.
Happy New Water Year.
New water year starts October 1st. Looks like our precipitation yesterday has gotten us right on track to where we should be. It's very hard to see, but there's a small green step that happens right there. So yay for being chronologically on track with water, or with rain. Soon, I'm sure we'll start to see the snow.
Not too soon, hopefully.
Snow update. I guess it wasn't last year, it was 2 years ago, right, 2019, where I think it was mid-October, we started to have a
There's
large
2 years
snow
ago,
event.
yeah, 2 years ago.
It was like Halloween, right? Didn't it snow on
Yeah,
Halloween?
there was two. There was one, I think, prior to Halloween, where we got at least some measurable snow, and then another the day before or 2 days before Halloween. I remember distinctly seeing young children walking around my neighborhood in T-shirts, but there was snow. Welcome to Wisconsin.
Yeah.
Or not T-shirts, but their costumes.
Pretty snowy.
Yeah, so last year, or 2 years ago, above average snow. So at least right now, it doesn't look like we'd be on track to get a lot of snow or early snow based on our current temperatures. Let's move on to looking at the short-term forecast, at least now. So this is approximately right now, looking at the forecast for using a GFS model. We see this poorly defined low system that is moving east, that's brought the Midwest some precipitation. We're gonna see kind of a couple different mid-latitude systems go through. You go forward to, sure, 18 hours. Good. So Saturday, 60, around midnight, we start to see another low pressure system coming through. Not super well defined right now.
Well, I was going to point out about that low coming through. There's a series of shortwave disturbances moving inside the longer wave trough. This is the first one coming through, and you can see some snow starting to break out in northwest Wyoming.
Yeah.
And this becomes quite intense. It goes to blizzard proportions in about a day or two.
Yeah.
And I think it's the next wave coming. Go ahead with that.
There's also a tropical infest area based on the synoptic setup, it looks like we might get a little bit of interaction with the coastal Carolinas, but the majority of the storm is going to likely stay off the continental U.S. It shouldn't develop too much, so we'll kind of ignore that. But as a tropical person, I had to point it out. But yeah, so we get a series of low pressure systems associated with short wave troughs. So this is the first one. If you go ahead into 24 hours, we see it moving through. If you actually go 30. So the SPC tomorrow has, I believe it's a slight risk in northern South Dakota, Minnesota, North Dakota area. So there might be some severe weather up there. Nothing too intense for Saturday. If you go ahead to 42 hours, or 45 hours, hours. So yeah, that's this low pressure system might bring some severe weather in this area. You can jump to the SPC later to look at some of those risks. Saturday or really Sunday doesn't have that many. It's not that severe of an event. You can start to see, if we go then another, So now Sunday afternoon, another low pressure system from that short wave trough that we're not seeing. It's developing. This time it's going to propagate a little bit more east. This one, Sunday, there is a moderate risk, I believe, in Oklahoma, United States, associated with this low, with some damaging wind and hail and possible tornadoes associated with it. I guess actually in this forecast that tropical system is making landfall with
That seems to be much stronger than it was on the previous route, the one on the East Coast.
Yeah.
Whatever that is, yeah.
So I guess we'll have to look out for that. As we go forward another 12 hours, see that system developing, starting to see a bit more of a warm sector associated with it, and a cold front, warm front, some precipitation associated with it, so some severe weather is potentially going to happen in Oklahoma. We're also starting to see some lovely snow in the northwest. That system ahead of it is moving out. Keep going another hours. System, what?
I was gonna say that would be 12 hours, right?
That system is continuing to move north. On Monday, Tuesday, we should probably be getting some precipitation from that system as it passes over us. I think Tuesday there's also a risk for some severe weather associated with it. And I believe this is the snow event that's starting in Wyoming, southern Montana. I haven't looked at that.
It's earlier, it used to be on Wednesday, now they're all the way up to Monday on it. But, see what it's gonna do.
Yeah.
Oh, there's a series of waves going through there, so.
Yeah, so it should be pretty active next week as far as weather happening over the continental U.S. So we'll probably have a lot to talk about it next weather watch.
Oh, look at that,
You know
it's back in Colorado again. Denver Boulder might feel this one. Look at that.
Yeah.
It was, a couple days ago, it was on the front, oh, and then they removed it, here it is again. 13, yeah. So it looks like they'll get a few inches, not a blizzard in Denver, but it'll be their first snow in Denver, Boulder.
Yeah, and that system is starting to develop into a much more classical looking mid-latitude cyclone. The cold front is moving southward, nice warm sector, some warm. We're going to stay atypically warm through the next week, it looks like, as the system moves through as a series of shortwave trough-initiated low-pressure systems and cyclones are moving through the continental U.S. So it should be a pretty active week as we go through. Looks like we'll also be getting, the U.S. will be getting a decent amount of rain, which in most places is pretty necessary. So,
We may be getting some severe weather with that too.
yeah.
Step that ahead a couple frames.
Or, yeah, I guess we can do that. Yeah, we could definitely Thursday see some severe weather from it. If we, let's exit out of this and go, I think, of SPC Outlooks. So this is today's outlook at the Storm Prediction Center. Broadly a chance of thunderstorms with 2 marginal areas, which is where we see some severe thunderstorms currently. Every other day too. Again, there's a slight risk of severe weather in the triple point between South Dakota and Minnesota, associated with that low pressure system that we saw earlier. Day 3, again associated with the low pressure system and its cold front. We see this enhanced area for severe weather in Oklahoma and Texas, so that will be someplace to look out for. In day 4 through 8, day 5, we also have probability for severe weather. So that's Tuesday. We are also seeing with one of those low pressure systems going through. I think that's about it for what I've looked at and what I've done. If there's any questions? Thanks for coming. Have a nice.
For any other students, if you want to do a weather watch some week and go ahead and do this, let us know, because it's great to watch Michael do it, but it's nice to have other people.